Hey, Mr. Sams.
Yep.
Hey, what are you doing?
Playing with Velcro and zippers.
You're doing what?
I'm playing with Velcro and zipper. Ooh, look, a snap.
What? Why would you play with Velcro snaps and zippers?
Because it's fun. Oh, no, and it bonds things together. These are ways of sticking things together, so I can stick things together.
So you can stick things together.
I can stick things together with my Velcro or the zipper, whatever.
Well, that's kind of like bonding, isn't it?
It is. These things bond together. So there's like a Velcro, you got the fuzz.
And you know what we're talking about today in class?
Loops. Bonding.
Bonding! You are just brilliant.
I know.
I know. You're amazing.
This is just, I just love this.
You just, you must have small children at home.
I do.
Yeah, I can see. Yeah. Okay. All right. So today, folks, we're going to talk about
Bonding.
bonding. Okay, Mr. Sams, here we
Yeah,
are.
that was
Chemistry Podcast 2.5. You and your bonding thing, your Velcro deal.
Oh, that's great.
Yeah.
I just can't stop.
You're amazing. I tell you, the small children must just keep you going. But we're talking about bonding. What do bonds do?
They stick atoms together.
Yeah, so we've got like atoms. And do atoms really look like this?
Not really. That's just the way we show them so we can kind of visually...
Yeah, so kind of like this stick in between here. That stick is like a bond.
It represents a bond, but that's not what a bond looks like.
Because actually they're kind of like connected together.
Yeah.
They kind of overlap. Their orbitals overlap. We'll learn more about that later. But the key thing is we're going to talk about the different varieties of bonds in chemistry.
Yeah.
All right, so let's start with ionic bond.
Ionic, yeah. There's three types we're going to talk about. The first one is ionic, and in an ionic bond, we produce ions. And ions, as we know, have positive and negative charges. So, in order for something to get a positive charge, it has to lose an electron, and for something to get a negative charge, it has to gain an electron. So when we build an ionic bond, we take two elements, and one of them loses the electron and gives it to the other one, so there's a transfer of electrons going on. So that's key. An ionic bond happens when there's a transfer of an electron, and a transfer occurs from a metal atom to a non-metal atom.
All right, so folks, if you're seeing this, we've got this arrow, kind of a funny looking arrow right there. That is the transfer of this little dot. This dot right here is the electron. It isn't really an electron, it's a representation of an electron, as it moves from the Na, sodium, which is a metal, to the chlorine. Another thing that's very important for you to write down is that an ionic bond is a bond between a
Metal and a non-metal.
To a non-metal.
So take away ionic bonding, there's a transfer of electron, and it's between a metal and a non-metal. And Mr. Bergmann is having pen trouble.
Yeah, I'm having pen trouble. Okay, here's actually kind of a animation, as you can see. The sodium, he's giving up his electron, and they connected. Let's kind of go back and watch that again, everybody. Right. So if you watch that again, the electron transfers, energy is given off, then the two guys get connected. Now the reason they got connected there is because the sodium has a
positive charge.
Positive charge, just going to repeat, I guess. And then the chloride has a negative charge.
And they opposites attract.
Opposites attract.
So they attract each other.
That's exactly
right. Call that an
right.
electrostatic attraction.
And then when they form what's actually called a crystalline lattice, where we have the negative is the green and the positive is the purple, and it's just an overlapping NaCl.
Yep.
So if this was sodium chloride, actually one thing that's interesting about this, when we say it forms a crystal lattice, is it's not like there's one sodium connected to one chloride.
No, that's just the ratio. For every one sodium, there's one chloride. If this were calcium chloride, it'd be a 2-to-1.
So, for example, with sodium chloride, you might think of it as Na1000, Cl1000.
Right.
Or
we always
billions.
reduce it to the lowest.
Lowest whole number ratio.
Right.
Okay, well, so ionic bonds are bonds between a metal and a nonmetal. Remember, metals, we learned this earlier, metals are on this side of the stair step, and then these are the nonmetals, okay? So bonds between metals and nonmetals. So let's watch a short little video about ionic bonding. Well, here I am at the University of Colorado at Colorado Springs, and I want to talk to you today about ionic bonding. Now, an ionic bond is a bond between a metal and a nonmetal. I happen to have brought with me an ionic compound. Salt.
Salt?
Salt is an ionic compound. Let me pour some in my hand. Salt, of course.
You mean I eat chemicals when I eat salt?
I know. So if you look right there, that's sodium chloride. Sodium bonded to chlorine. And when you bond the sodium to chlorine, you make a ionic bond. Another example of ionic bond, in the backdrop over here, if Aaron turns, you'll see Pikes Peak. Pikes Peak is made up of Pikes Peak granite. Granite is a mixture of many chemicals, but all of them are ionic bonds. Metal bonded to nonmetal. And that's an ionic bond. Well, now we've got a different kind of bonding.
Covalent bonding. Now,
Covalent
this
bonding.
is sometimes called molecular bonding.
Molecular? Can you say molecular, everybody?
Yeah.
Okay, molecular bonding.
And it forms covalent compounds, which are also sometimes called molecular compounds. It's just two different ways of talking about the same thing.
Now, guys, the word covalent is actually good to understand.
Together.
Together, like cohabitation or
Cooperation.
cooperation, or
Coca-Cola.
no, I don't think so.
No? Okay.
That comes from the coca plant, and that's a whole nother.
Oh, that's a whole
ballgame.
nother ball of wax, isn't
Yeah.
it? All right.
Yeah, I was in Peru one time, and they
Yeah.
have coca plants. That's a whole nother deal. Yeah.
Yeah.
Okay, covalent means sharing something.
Valence.
They share valence.
Valence electrons.
Yeah.
Ah, okay.
Remember, they're going to share. Oh, maybe that tells us what covalent bondings
Yeah.
are. It is sharing. I better write this down. Sharing valence, V-A-L-E-N-C, valence electrons. There you go. So our picture right here, we have a hydrogen atom with his one electron, and what he does is he meets up with another hydrogen atom
with his one electron.
With his one electron, and
then
they
share.
share.
That's nice of them.
Oh yeah, yeah.
Yes.
Do you teach your kids to share?
I do.
That's good.
Our son's good at it. The girls not so much.
Well, yeah,
they're kind of small.
they're still too young. It's
Yeah.
mine.
Exactly. Yeah, both of them just learned the word. I have twin daughters, by the way,
Yes.
in case you didn't know that. Yeah, mine.
Yeah. So a bond between a covalent bond is a bond between a. Actually, we should say this before. Is bond between a
Two nonmetals.
A
Non-metal
nonmetal.
and a non-metal.
to a non-metal.
Right.
So where would we find those on the?
Those are to the
periodic
right of the staircase.
So here's my staircase right here. So it's going to bond between these guys and themselves. And what's...
And hydrogen.
Yeah, but remember also there's a weird deal. Hydrogen
Yeah.
is not a metal, so he kind of also can bond like that. So
Yeah.
a classic example like water, H2O.
Yep.
Water is a nonmetal bonded to a nonmetal. H's and O's are both nonmetals, and they share their valence electrons.
They do. Then they form covalent bonds or molecular compounds
Yes.
or covalent compounds. Same thing.
Why don't we watch a short video
Let's-
on molecular
let's
bonding?
do it.
Okay. Hey, I brought some sugar today, Mr. Sam.
That probably tastes better than the salt we were playing with earlier.
Yeah. Tasty brown sugar. Now, I'm talking about brown sugar today, guys, because sugar is held together by covalent bonds. Sugar, or this is sucrose, is C12H22O11. And it's got carbons, hydrogens, and oxygens. Carbons, hydrogens, and oxygens are all nonmetals. Therefore, this is held together by a covalent bond. I think I'll have some more. Very good. Okay. And the last kind, of course, is a
Metallic bond.
metallic bond.
Yeah,
What's
gee,
a metallic bond?
I wonder. Probably between
Metallical
metals.
things.
Metallica?
Metallica? Is that like that? Oh,
Metallic? Oh, yeah, that's metal.
Yeah.
Heavy metal.
Heavy metal. Oh,
Yeah, that's
there you
good
go. So what's up? So this is actually a bond between a metal and a metal.
Metal. Yeah, and it could just be the same metal. It's the bond, like here we have some copper wire. That's just copper atoms. So it's the bond that holds those copper atoms together that make it a solid.
Yeah.
If atoms aren't held together, they're gases.
Right. So this is just a spool of some copper metal that it's all held together.
Yeah, no, we could also mix some metals and make an alloy,
Yeah.
and those would be held together by metal bonds. So if you take, iron and put a bunch of other metals in there, you turn it into steel. So it's a bunch of different types of metals, but they're all metals, so they're still forming these metallic bonds between
Let's
them.
actually talk about an alloy in our video clip.
Oh,
Okay.
yeah.
Okay. Actually, metal to metal. So
yep, to the left of the staircase.
metals here,
Including
two
those guys down
metals.
the bottom.
Yep, those are all the metals right there. Oh, not including hydrogen. I messed that up. Okay. So let's do a little metallic bonding.
Mr. Bergman, why do you have a bike?
Well, it's kind of light. It's,
Yeah, and I know you like to ride bikes.
Yeah, this is like my old bike. I decided to go against this bike because it's got this like rear shock, and I kept racing these guys, my friends, and they all had hardtails, and I would like lose all my energy and lose going up the hills. So I decided I was going to switch out the bike.
So this is the old bike.
This is the old bike. The new bike is similar, but
Let me
doesn't have the
guess,
dual shock.
you're going to sell it on eBay.
Yeah, I think so. But the cool thing about this is it's made of a metal. It's made of aluminum. Now, sort of. It's actually an alloy of aluminum and some other chemicals to give it a certain amount of rigidity. But this is aluminum, which is a metal, and it's a metal bonded to a metal, which makes it a
Metallic bond.
metallic bond. So this is a metallic bond. Now, that's not the only thing. You could also look at my ring. I have a gold ring on. And this gold ring, of course, is a metal bonded to a metal. It's actually alloyed. Pure gold, interestingly enough, would be too soft. And so gold jewelry is not made of pure gold. It's alloyed with other chemicals. So this is a metallic bond.
Okay.
Oops. So I'm just saying that's our summary of metallic, ionic, and covalent bonding.
That's it. Now, what happens to the electrons in a metallic bond, Mr. Bergmann?
Well, there's kind of like this commune thing going on there.
We want to talk about that now, or should we talk about it some other time?
Well, we can do it now.
All right, let's talk about
So-
the metal commune.
So if you've got the metal commune, you've got metals, of course, in the center is their nucleus.
Okay.
And they have a positive charge, all nuclei. And then the electrons don't really belong to one of them, but to like all of them.
Oh.
So if, let's say for example, the electrons of everybody's happen to sort of live on this side of the structure, what charge would that have?
That's going to be somewhat negative.
Yeah, negative. And that, of course, that makes this side positive.
Yeah.
And since this is positive and this is negative, they're attracted to each other, and therefore
They stick
stick
together.
So that's what's going on. So
Oh,
if you look at
interesting.
my bike, as we just saw just a minute ago, in that bike there's electrons moving around. Kind of.
The electrons are moving in your bike?
Yes.
Weird.
I know. It looks like it's static, but it's actually the electrons are
Yeah.
moving, and that's what holds
So
it
the
together.
electrons aren't yours, mine, they're
Ours.
our electrons.
Okay.
Interesting.
Well, that's our quick introduction to bonding. We'll talk to you later. Bye.
Bye.